channel. So today we will be discussing a project on human faces detection from image, or we can detect from multiple images also. So we will be doing this project in Python. So let's take an example how it will look like. So this is our input image and this is our output image. So in this image we can see there are four faces. So all four of them are marked by a Python script that we will be writing. So faces detection, we will give an input image and we will get an output image that will be having all the faces marked in that image. Now let's what is prerequisite to this project? Python and OpenCV. So if you do not have OpenCV on your system, you can install OpenCV Python. Then you will need a HaarCascade frontal face default XML file that is a model for face detection. And what the data is required? You will need images to detect the faces. So I am using an Splash. It's a free image source. And the HaarCascade file you can download it from GitHub or you can find it in OpenCV data itself. So now we will look at the steps involved in it. So the step one, we will read or open image using OpenCV. Then OpenCV reads images in BGR format. So we will convert BGR to gray because our XML model accepts images in gray format. Then we will detect face coordinates from that gray image. Then we will draw those green circles on the original image, that is colored one, and then we will show that image in the output. So that is the whole pipeline of the project. And now it's time to code. So let's jump into the Jupyter notebook and I will show you how to do it.
So let's start with the coding. I will create a new notebook. So if you are new to the environment, you might not have installed OpenCV in your environment. So let's install it. So pip install OpenCV and we need to write Python. So for me, it says requirement already satisfied. So OpenCV is already installed for me. So I will start with importing it. Import CV2 as CV. So remember that while importing, you need not to write OpenCV Python. You just need to write CV2. Next, we will import is matplotlib. Matplotlib dot pyplot as PLT because we will be using PLT to show the images we will be generating. And then we can show with CV2 as well, but we will be using for the simplicity because image would be a numpy array. So let's import numpy as well. Import numpy as np, and when I will run this, all the imports are successfully imported. So next is let's read an image. So if we will go to image equal to cv dot imread, and then we will give a path of the image. So for me, those images are stored in this folder. So if you look at, I'm having 4 images. So let's first we will be reading is person.jpg, and if I will show the image, so this is the image, and you can get these free images from the Unsplash. So coming to the again code, I will write images, then the person.jpg. So this is my reading part. So once I will read the image, I will look at what it is. So first thing we can do is we can say type and then image. So it's numpy nd array. So let's check how many dimensions it has. Image dot ndim. So it will say we are having 3-dimensional array. What is the shape? That can be checked by image dot shape. So we are having 4240 2832 by 3. So these are the channels, and if you want to check all the number of elements in it, that would be img dot size. So these are total number of pixels or the values inside our array. Now let's look at the image in the Python. So we will be using plt dot imshow and we will pass image. So if you look at this image from the original image, it's a different one. So if you look at, the colors are not matched according to the original image. This is happening because while reading the image in OpenCV, it is by default loaded in BGR, not RBG. So if we go at the documentation in OpenCV, OpenCV Python tutorials, you can look at for more details in these tutorials of the documentation. Now coming to the imread. So this is imread, what we are reading, and in Python we used to call cv.imread and the file name. But if we look at this second point in notes, in the case of color images, the decoded image will have the channels stored in BGR order, not RGB order. So let's convert this. How we will do it? we will be using OpenCV to do it operation. So let's say we will call it image, then RGB. This is the new order. So we will call CV dot and CVT color. In CVT color we will pass image, the original image, and then CV dot color, and we are having right now BGR, and that we need to convert to RGB. RGB, this one. So let's say we converted this. Now if we look at the image, PLT dot show, and if we pass image RGB, then we will find this is the correct image or the correct order of the channels. Now let's look at some plotting tools in the OpenCV. So let's say if you look at the axis, this is x-axis, this is y-axis, but if you start, this starts with 0 here, and for y, it's when we come to down from the top, it will increase, and for the x, if we go from left to right, it will increase. It's top to bottom and it's left to right. So to show this, let's say we will create a 100 by 100 pixels image with all 0 values. So we can say, so let's take an example and see how the rectangles and other shapes can be plotted in OpenCV. So very first is, let's say we will take example image, how we will create it? Just numpy array. So np dot, we will create array with all zeros, and we will pass the shape as 100, 100. So this is our example image. Now let's look at it. So we will say plt dot show, and we will pass example image, and we can say cmap equal to gray, because this is one channel. So it's all black, there is no plotting. Now if I will show the grids, plt dot grid, and then plt dot show. So if we look at x-axis, 0 starts here and it ends 100. For y-axis, 0 starts here and it ends here. So now let's say if you want to draw a rectangle at this box, so that is 40, 40, and then 60, 60. So how we will draw it? We will say on the same image, so we will say cv dot rectangle, and then we will do is pass the image itself. So our image is example image, and the coordinate of x-axis. So first coordinate would be the top left corner for the rectangle. So it's 40, 40. Next is we need to give height and width. To draw rectangle on this, we need coordinates of this or the height and width. So height and width are 20, 20 for us. So 20, 20. After that, if you look at this, we gave 2 points or the one double coordinate, then we need to give color. But again, these colors are in RGB. So if we give 255, 0, 0, these are in BGR order. So the rectangle would be in blue, but this is not a colored image. CMap is gray. So we will see that will be a white box. Now color and thickness we can give 5. So it has created a rectangle on the image. And how we can do it? Let's say we will assign this to again the same image. Now if I will plot the same thing again, it has a, okay, let's say thickness is too much, so we can give thickness of 2. And again I will create an image, the grid, and then we can plot. So with the thickness of 2, how it looks. So this is rectangle. If you want to plot a circle, so that we can do. Let's say we will reassign the image and put 0, then example image, and in circle we don't need to pass this, we will give just coordinate, and instead of 40, 40, let's give the center coordinate 50, 50, and then we need to pass radius to it. So let's say we are passing radius of 10 pixels, so it would be touching both, as diameter would be 20, and instead of rectangle we can say circle, and then we can show the image again by calling show. So this is circle. So I hope our drawing on the images is clear, and keep in mind, in coordinate system generally we used to start 0 to 0 and then 0 to y is increasing in this direction, but here y is from top to bottom, not bottom to top. So given that, now let's load the HaarCascade model. So for HaarCascade model, if you want to read more, you can go to this cascade classifier. This is theory. This works on the edge detection, and cascade means we are having multiple layers of the features, and in the few of the first steps, if we do not find any face features, we will discard that window and we will move on. So to increase the efficiency. And if you want to read more about it, the original paper is this one, rapid object detection using boosted cascade of simple features. It was from 2001. So this paper is from 2001, and it was proposed by Paul Weiler and Michael Jones. So let's load the model. We will say model equal to cv dot cascade classifier. Then we need to say model dot load, and what we want to load, I'm having my XML file in archive. So archive, then we can say HaarCascade, and I will load frontal face default. So I have loaded my model. To detect faces, we need to convert our image to gray. So if you look at our image, that is img in BGR order, let's convert this to gray. So I would say gray image equal to, how we will convert, cv dot cvt color, then we will pass our image. Let's convert this to gray. So cv dot color, and right now we are having BGR, so BGR to gray. And if you look at this image, plt dot show, or let's say just do the shape, gray image dot shape. So from 3 channel, it's just 1 channel, that means it's grayscale image. So now we will pass grayscale image to for detection of faces. So we will say faces equal to model dot detect multi-scale, and we will pass the image, that is gray image. Then we will pass the scaling factor, that is let's say 1.25, and 8 nearest neighbors. And now if you look at the faces, these are the coordinates of rectangle and its area of array. If you look at the shape, it's 1, 4. So this has one face, and the 4 these are coordinates of the images. So it's x, y, and width and height. So to draw this, let's do this for face in, we would say face in faces, because this is faces, and we would say x comma y comma width comma height is equal to face. Okay, so then we will press enter, and if we want to draw a rectangle, we will say cv dot rectangle, and we will pass our which image, RGB image we will draw on that. So to draw what we need, image, then the coordinates, so we can pass x, y, w, and h. And to draw, let's say we want to draw green, so 0 comma 255 comma 0, and we want to draw, let's say, width of 5, and so this has drawn on that 0, we will see a green. So we detected face successfully. If you want to detect it for the, let's say, multiple images or the like multiple faces, let's read another image, that is let's say we will call meeting img equal to cv.im read, and we will pass images, and so that is group meeting.jpg. And if we want to look at the image, so first we will convert into meeting img to grayscale, and we can call it gray, and we will see cv.cvt color, and we will pass meeting image, and then we will pass cv dot that color, input is bcr to gray. So now we converted this image to gray, and we can look at plt dot, I'm sure we will pass meeting image gray, we will say cmap equal to, what would be cmap, it's gray, let's give it to gray. So if you look at, this is a grayscale image. Now there are 4 faces, let's try to detect it. So again, model is already loaded for us, so we would call it as a faces equal to model dot detect multiscale, and we will pass the image, that is meeting image gray, and what is the 1.25, and let's say take 8 nearest neighbors. So then if you look at the faces, we see there are 4 faces, and these are the coordinates. So to start, let's plot them. For the plotting, what we will do for face in faces, what we will do, cv dot, let's put rectangle, and what we will pass the original image, that is meeting image, comma, we can pass as a coordinates face, and then the color, let's put again green color, 255 0, and width of 5. Okay, now let's convert this meeting image to RGB for our viewing purpose. So we will convert it cv.cvt color, we will pass meeting image, and the cv dot color, that is pgr to RGB. Okay, now plt dot I'm sure, and we will pass meeting dot RGB. So if you look at the output image, we are having all of them are green boxes. But let's say instead of drawing a rectangular box, if you want to draw circles, so what we can do, in this instead we will pass circle the image, and instead of passing these coordinates, we need to take x comma y width comma height, and then we will call it face, and it takes only the center points. So center point would be x plus w by 2, width divided by 2 x center, and then for the y center would be again y plus height divided by 2, and then we will pass the radius, let's say we will pass in radius of 400, the same color and everything. So let's read image again from this place, again the 4 faces, but this time we are drawing circles. So this is our output. So thank you for watching, and if you want to write the image to output, you can write cv dot I'm right, and it takes file name and then the image. So file name we will write it into the images, then we can call it as meeting faces dot jpg, and what is the image, that is meeting RGB. So if you run, that's true successfully. Now let's go and check images in the folder. So if you look at images, we are already having meeting faces. I will open this and I will edit it, so we can see we are having. But what we have done, we made a mistake because we didn't write the image, that is BGR order. So let's fix that. To do this, we need to write RGB. So we are writing RGB, but it reads that way. So let's let it be in that way only. But if you want to write in this order, what we are seeing, so again we need to do conversion before. So that is cv dot cvt color, we will pass image, then we will pass cv dot color, and that is RGB to, okay, it's RGB to BCR, and then we write this, it's true. Now let's go again to images, then if you look at the meeting faces, it's the correct one. Okay, so in the previous one we wrote in the reverse order, but now if you look at, this is the correct order. So thank you for watching.